Wah! Hello, everyone. I mean, closed caption is not on. But I turned it on. I'm seeing closed captions. You're lying to my face. Yes, that is fantastic. Well, everybody. Nice by a portion of Pyrex. Hello. Welcome on in. I wasn't anticipating initially thinking about building more than one of these, but I have the parts and the boards, and I'm kind of in the mood to make another one. So if you didn't see it last time, I'm doing it again. I also have some smaller resistors for the 47 ohm. So this set should actually fit in the board without sitting up. I'll show you the comparison because I have the ones that I built here side by side with the one that we're going to make anyway. So the rules are still the same. The green LEDs still need to be installed backwards for them to function correctly because I messed up the diagram, but that's okay because it's still gonna work. I'm gonna show you. I did some stuff and things. Let me switch this over here. And this camera. Okay. I also have a different radio station on. I did this. This is chiptune playlist on Pretzel Rocks. So it sounds mighty fancy. So I'm kind of like, I like this. Let's keep using this. Exactly. Yeah. Just build. Just do the thing. That's what we're gonna end up doing here. So, all right. Let me get us sorted here. So as I had mentioned, I did build one of these. This is the one I actually built for last time, but I wanted something to stick it in so that, you know, the traces weren't sticking out, because I do plan on wandering around with these for a little show and tell purposes. So I built this three-dimensional case that just lines up at the bottom. I gotta figure something out here about either something to reuse the holes that are on here, but the reality is, you know, board, pointy objects, all that fun stuff, less pointy. So I have that, but to mention here, ads. Why ads? Why are you gonna be like that? I'll give it a hot second. All right. While I'm waiting for you to come back from ads, I'm gonna clean my glasses. Furry5, thank you for the follow. I am TechHead41. I do silly things on the internet. I talk about technology. Today we're building something, which is going to be a more common commodity on this channel because I like it. This just so happens to be one of those projects that I kind of did in the background to figure out the custom board, and then here we are. We're going to put another one of them together. Let's see here. And we're back. Fantastic. Okay. So yeah. Last time I was mentioning that the resistors were like these are flush. These are the 100 ohm, but the 47 ohm ones that I did last time are installed here at a bit of an angle because they're too big. I ended up getting 2 watt ones instead of like 1 watt, so they stand up a little bit in the board. But the ones we're going to use today are still 47 ohm, but they're the 1 watt ones. This application requires about 1/4 of a watt, so these are still well under the power requirements, and they'll lay flat on the board. So aesthetically, they'll be a little bit more pleasing. That's what I'm going to do. So similar as last time, we're going to have our board. I pulled some of these components ahead of time. Alright, let me see here. My iron fell asleep. Wakey, wakey, child. Alright, let's go back to target. Beautiful. Alright, that's heating back up. And then I believe... Oh, you know what I didn't grab? I didn't grab my little... Exactly, Porsche. Exactly, because the reality is that this Pronoun switchy board do-jobby thingy that I came up with. Allows you to switch through the different positions of pronoun configurations on one board. So for those of you who didn't see it last time, this is what the finished product is going to do. Turn on switch number 1. You get a she for he. You turn on the second one. You get she. The S, the H, and the E are on. And then if we toggle off the S, and we toggle on the third one, we get they. My Y isn't exactly the best, but it's still your brain kind of auto completes it. I could have did a bit of a better design on that front. Or you could turn them all on and get they. So yes. And that is running off of a 18650 rechargeable lithium-ion battery. Now, the most important thing about this is that this is the protected button cell, which means that when this cell gets below its nominal voltage of technically 2.5 is the cutoff. The nominal voltage is 3.7, but once it hits cutoff, the battery itself stops putting out voltage. Why is that important? Because these type of cells will fail if they don't stop themselves. So these batteries are sold in protected and unprotected formats. Some devices require an unprotected battery because the protection circuit is built into the application. Mine is not like that. This requires a protected battery because this board doesn't know when this is out of voltage at a safe level. So this is a protected cell, and it could be any protected 18650 battery. That's just the size and diameter of the battery. It's the type of battery. If you Google 18650, that number, you'll come with up a bunch of these little things. That protects you and the battery, because if the battery does not have its protection, if this was an unprotected cell, once the battery gets low enough, the battery will fail. That either just causes permanent damage to the battery and it won't charge anymore, or it could blow up. Lithium-ion cells vent under extreme conditions of stress, over voltage. I don't know if they'll vent on under voltage. I know if they get too many volts in them, overvolt they will. But all I know is they just don't misbehave with the battery, and it's fine. Okay. Is the board a pronunciator? Listen, I heard that there's a new season of Phineas and Ferb, and I can guarantee you the pronunciator Ray probably should come in a future episode. What do I know, though? What am I feeling here first? Last time I did the LEDs later after I did the battery holder, but then the board didn't really sit flush the other way. Kind of want to get the LEDs to sit a little bit more flush this time around. I don't need my garbage can. Yeah, good. Because anybody who watched this last time knows that once I solder the ends, I have to clip them. Anti-discharge. Yeah, you know what's funny? These cells don't go spicy pillow because they have a vent that's hidden in the top of the cap here. It's like right underneath this ring is a hole that's protected by the plastic shield. But if the gas is built up in the cell, it expels them violently out of the top of the battery. Spicy pillow syndrome is the lithium batteries that are naturally in like laptops. Those type of cells don't have a vent in them, so that when they fail, the gas is built up in the encasing of the battery, and then instead of venting in a fairly violent but yet controlled manner, the spicy pillows just grow until either they pop or explode. Again, with all very flammable gases. So 10 out of 10 would not recommend. But I'm getting sidetracked. I think I'm going to build this one backwards. I think we're going to do the LEDs first to get them all nice and flush. Because when I flip the board upside down and then apply the solder, that will make them a little bit more installed. I should have enough green ones. I'll count to see how many green ones I have.
Because if I don't have enough green, I might use yellow. Actually, wait, yellow was 2 volt. Green was 3.3. I might... Okay, so the reason I went with green for H and E is because the color itself kind of falls under the umbrella of being more gender neutral. I didn't want to go with blue for he because that's a more targeted color. What I suppose I might, I don't know, I'll come up. We'll see what I come up with. I already forgot which orientation to do this in. Log leg is positive, right? Yeah, log leg is positive. I don't know. I haven't made up my mind yet. It's easy enough to come up with that, though. Hi, Pine! Pine, I sure hope you are excited about the upcoming weekend. The amazingness. It'll be very exciting. And in my excitement, I'm gonna build something. Because I can. Well, I mean, yes, the idea though was that it's accepting and yet pride oriented. I could assure you these colors were not chosen completely at random. There was some thought involved in that. Not everything I do involves, you know, that level of detail, but this one just so happens to fall underneath that umbrella. Now, something I am doing, though, before I install these LEDs into the board, is I'm checking to make sure that they function. LEDs require a limiting current resistor, which is why you're going to see so many of them in this particular project. But more importantly so, we want to make sure that we didn't get a bad LED from the factory before I install it into the board. Oh yeah, Pine, yeah, let me show you. No, it's not a perfect solution, but this is what I came up with. It's just a 3D printed shell that has a little bit of a notch in the bottom, and I'm gonna figure out, I'm either gonna punch through to meet these holes, but it's just a simple smooth backing so that I can carry it around and, you know, not get jabbed by the traces that are on the back. Naturally, I had to get the dimensions, and I misprinted that probably about 4 times before I got it right. Which naturally, I don't think I've ever designed and 3D printed something and actually got it right on the first try. Because the thing is that, excuse me, when you use exact dimensions, when you're producing something that's going to be 3D printed, there's variability in the 3D print, and every time I use exact dimensions, and I should make it slightly a little larger to accommodate for the fact that things don't print perfectly. I never learn. It's troublesome though, because 3D printed objects have some skew to them, and it's difficult. It's difficult to get the dimensions right. Oh, I can imagine all the circuit boards in a camper. I mean, the reality is you're making an entire living space mobile, so there's a decent amount of electronics and stuff that would happen in a larger living space compacted into something that's more mobile. So I'd imagine that there's a decent amount going on there. Just in heating and cooling alone, I would imagine that'd be a little involved. Because all the relay boards to control the heating and cooling would have to be in a compact setup, naturally. A 1 and a 3 amp fuse. What were they, like automotive fuses? Or was it something more robust, like a I guess technically that's still an automotive fuse. I'm thinking of like that the higher amperage fuses that generally look more like big thin sheets of metal, or like something you would locate like in a fuse box under the hood most of the time. So I'm thinking of. Like an auto fuse. Okay, that makes sense. Because I almost wouldn't have been surprised if you said it was something similar to the fuses in a oh, we got one more that makes it the S. Like the bus fuses that are in like a breaker panel box. Some older homes, like particularly like 100 amp service homes, some of them use bust fuses instead of breakers, depending on how old the house is. Yeah, I know they're not the most comfortable thing to work with, but I mean, as long as you find the fault first before replacing it, then it's not too bad. Stinks if you end up going through a bunch of fuses though while trying to figure out where the problem is. It's one thing to reset a breaker, it's another thing to waste several fuses trying to find a problem. I actually had an old apartment that had a bad breaker, and it was funny because it was like right after I got my graphics card and I was super excited to use it, and then lo and behold, the every time I fired up Grand Theft Auto 5, I popped the breaker, and then I hear my UPS kick on, and I'm like, no, like, why you gotta be like that? I'm like, I'm here, I'm trying to have fun, how dare. I think this time I'm just going to go right across the board and do all the LEDs, because then I'll get them all nice and flush. This will arguably be the prettiest of the three that I've built. Click to the 7th power. Well, if you saw a lot of LEDs, more than likely those were different status LEDs of the different systems that do the heating and cooling in the camper. If it had anything to do with the HVAC system. Because a lot of the times on control boards, you'll see an LED that's associated with the status of a relay. And the relay will turn things on or off to enable or disable cooling, whether that's pumps or a cooling, or heating circuit. The LED is an excellent way to just quickly look at the circuit and at a glance know if the relay is open or closed. Just think of the relay like the switch in your room to turn the lights on and off. It operates in a very similar fashion, except instead of a human turning the switch on and off, the electronics physically move parts to enable or disable the circuit by physically moving a switch up and down. That kind of thing. Which is why in the automotive space that when you turn your key, you hear a very minute clicking sound when you turn the key over. And that is because a mechanical relay has activated, because the microcontroller informed the starter, okay, it's time to start the engine. And then it completes the circuit, and then the starter goes boom, 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 and then the car starts. After many spins, the engine goes, okay, I'm doing stuff now. Got it. I mean, granted, for any length of time any of you may have spent around my channel, you'll notice that I tend to talk a lot about cars in comparison to how computer stuff works. Only because of the fact that I find that car stuff is more relatable than computer stuff, because not everybody will have, the type of computer or component or setup that I might be talking about, but just about everybody's been behind the wheel of a car, whether you've been driving or simply a passenger. Just being around the sounds and different behavior of being in one of these vehicles tends to be a little bit more common, which is why I find it to be a wee bit more relatable when talking about this kind of stuff. Oh, the good old days when there's no microcontrollers. Yes, when everything was carb injected. Some carburetor action. It's not starting, get the carb cleaner! Also, try not to set your car on fire. I have seen way too many videos on the internet of people using carb cleaner or brake cleaner to start a car. and then their engine bay is on fire. I'm like, guys, can we do with a little less fire, please? I mean, it's okay, Porsche, I don't either. Like, I know, I only know what I know from cars from just all the time. That, I've either worked on my own or I've talked to somebody about it, and the information and knowledge had transferred in some flavor of capacity. But there's one really fantastic video that I saw on YouTube from the YouTube channel Donut Media. I don't remember what the gentleman's name was, but he had a carb-injected classic. I believe he said from the 60s, and just the excitement on his face when they actually got the thing to turn over was nothing short of magical. Just that expression and happiness. It's nice to see someone get excited about something like that. People need to be less dumb. Pyrex, I'm not going to say you're right. I'm not going to say you're wrong. All I'm simply going to say is I understand. People tend to clean their GD and ACs. I don't know what you mean by GD, but ACs, I would imagine you're talking about the recharging the air conditioning in the car, which a good majority of the time is a leak in the system and it doesn't need to be recharged. It needs to be leak fixed. People claim that the bottle's cheaper, but in reality, if you spend $30 a bottle over multiple bottles and not fix the problem, then you're just wasting money. The external unit. Oh, okay. Well, yes. I mean, fixing the issue up front, of course, is likely more expensive than a bottle of refrigerant. Having to replace a compressor or the seal where a compressor is, or heaven forbid, you bust one of the lines that controls the low or high pressure side. But wasting money endlessly instead of just fixing the problem, I don't know, to me seems kind of wasteful. I do know that, money is a limited resource for a lot of us. And if that means the difference between spending $30 every couple of months versus spending a couple hundred up front, I can understand that. Oh, you're talking about, okay, one of the standalone units. Okay, I understand what you're saying, Porsche, like the ones on top of the camper. Roger. Yeah, well, of course, like that's like any other system. Right, exactly. People can afford $30 a good majority of the time. Some can't, that happens too, so then you kind of just have to deal with it. I don't know. I would like to see that if I could have one thing that I would love for the rest of the world to have, that would be just a little bit more curiosity on how things function. I know this is probably more of a me thing, but I find it fascinating to find out how things work. Maybe it may be something I never even have to work on, but just the quest for knowledge is just fun. I mean, I don't know, that's kind of always been a me thing, though. Whoop! As I almost dropped my LED. Well, I believe it's more of a common issue. Negative ice cream. Break out the funny popsicles. You know, the ones that look like cartoon characters that have, you know, gone through the Great War or something. You ever see those things that, like, you know, like a standalone like ice cream stand, where like it's supposed to be like the eyes of the character are like bubble gum, but like it looks like it's seeing something through the Great Cold War. It's very bizarre, those ice creams. I never understood that though, because bubblegum gets hard when it's cold. So like, why would this be a thing you would put in ice cream? Let me count my green LEDs and see how many we have here. We got 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 23 in total I need. How many do I have? 2, 3, 4, 7, 8, 10, 12, 14, 16, 18, 20, 29 is what I have. I'm gonna have enough. Perfect. Not gonna have many left over either, actually. That's okay. Yeah, exactly. Literally the SpongeBob pops. That's actually what was in my mind. You got it. You're not wrong that it's the idea of the least amount of effort and the least amount of money spent. But as history has told us in the past, and it's going to be truth again, that if you put a cheap solution in, that generally ends up being a cheap fix, which generally doesn't last very long. Welcome back. Yeah, I have to chuckle at myself a little bit, because it doesn't necessarily feel like this is the smartest activity to be doing when it's this hot outside. I have a hot iron that's set to like obliterate. The sun outside's mad. I can't help but chuckle at myself a little bit at my chosen activity. Yep, fair. I mean, whatever works, right? Yeah, I definitely feel like the LEDs are going in a lot better doing them first. I could tell the whole project is sitting a lot more flush. But to be honest, making something custom, it's been a long time since I've made something new. First time for the channel, naturally, but that's how we learn along the way, you know? Or are you heading back out to work on your camper, Borsch? Oh, okay. I got you. Want more subflooring. Oh, what are you replacing a like a laminate floor in a camper or something like that? I guess technically it could be carpet. Because technically you can put whenever you want. I mean, I suppose that's technically another living space. Oh, fixing water damage. Okay. Oh wait, Porsche, I have a question for you, as a matter of fact. Speaking of campers, have you ever come across a cursed bathroom in a camper? And what I mean by that is a bathroom that has carpet. I don't know how y'all feel about it, but to me that just feels cursed. Bathrooms shouldn't have carpet. It's a hot take, but it's my own. Feel something like tile or click together flooring is just a better way to go, because you can clean it easy. C-class campers, the vans, shower goes to carpet, but not a full bath with carpet. Okay. Well, I mean, it's sorry. So it's one thing for carpet to meet the bathroom at a threshold, but like for it to actually be like installed like around the toilet, in tub, or shower, is where I generally have my own reservations of that not really being a great configuration. I'm glad you agree. I don't think it belongs anywhere near the bathroom. Now, throw carpets in a bathroom are one thing, but like those you can take out and wash. But like permanently installed carpet is really the knack that I'm getting at. But again, that's one Puroto's opinion amongst the many. Mats are barely acceptable. Alright, that's fair. Sure, I can understand that point of view. Wet rooms are also not the answer. I don't quite know what you mean by that, Pyrex. I mean, if you're just simply saying along the lines that, carpet and areas where water should be kind of aren't a combo, then I am picking up what you are putting down. But if it means something different, I'll need you to clarify a little bit. Oh, well, yes, that's a fair assessment. You kind of you kind of can't tear that stuff out if you're living in a rental. Wait, now hold on a minute. So that brings a whole other question. All right, so now we have positioned ourselves inside of the home improvement store. Can someone explain to me why that when you're looking at the toilets that they're talking about how many golf balls, billiard balls, small pets, large pets, you can flush with one of these things? Like, I like that. Now, I also have to wonder if that's almost an American thing, like of other countries. I would love if there's anybody in this chat that's not from America. Please do inform us on what you guys have as comparative operators for what your toilets can do. Because us in America, we're a bunch of silly people over here. We talk about all the things that you should never flush in a toilet is the measurement to indicate how much power a flush a toilet has. This makes no sense to me in any stretch of the imagination. Oh, that's what you mean by that. Okay. Right, so at any point, technically speaking, if the floor was completely open, you could just run a squeegee and then everything goes right down the drain. Which, back in my younger years, I used to do that in some of the commercial buildings I spent in. It was a great way to clean the floor. Right, you never needed to flush a pet down the toilet, but please tell me you've actually seen the ads though. What I'm talking about in whoop, holding the wrong lead. Please tell me you've seen what I'm talking about. I can't be the only one to have witnessed this, unless maybe I only have a crazy home improvement store. Maybe it's just me. I can believe that. I can imagine that being a tech problem. Some of the sillies that we run into at the home improvement store. Have to use the bathroom at 3 o'clock in the morning. Listen, that's the time for a Krabby Patty. You cannot change my mind. But yeah, that's a good point. If you do have to go into a wet room and it's the middle of the night, heaven forbid you're wearing socks, you're going to have a bad time. That's all but guaranteed at this point. But doesn't that get to be a part of the experience, though? Just don't fall. Golf ball thing is mostly for suction power. To be honest, it's never see a real reason for it. I agree. That doesn't really feel like a thing. But then again, I feel like most people are buying a toilet based on solely the dimensions of the thing, not its ability to flush consumer hardware. But again, what do I know? I'm not out there buying toilets. All right, so we could switch back to white. Oh yeah, that definitely is a better layout for the LEDs. They sit so nice if you do them first, which makes sense because they're technically the tallest thing on the board right now. So hey, we learn, right? Trying this different ways actually kind of helps a bunch with that. It's gonna be a little challenging to probably solder the switch pack, but we'll figure that out when we get there. US flush a different way than the UK. Well, fair. I mean, I have seen different toilets set up different ways, because naturally that is not the same across all the different parts of the world. I mean, in some areas of the world, there's no concept of it being like a tank toilet. It's more or less of a... I don't know how we even got on this topic. It's fine. We're riding with it. It's more of something that you squat in front of, do your business, and then flush, but there's no tank or seat. But then again, even with in the US itself, I've seen a couple different designs that are like commercial toilets, right? Those are tankless. In most cases, they all get their flushing power directly from the water line, not through the idea of a tank. But then again, that's one less thing to break, especially if someone, I don't know, falls on their face when they're in the bathroom. Okay, you got to set up like that. Okay. Got ya. I've only ever seen pictures of a setup like that before. I've never witnessed that IRL. Makes sense, though. I have to admit, though, that has to be a little bit more challenging, though, if you have to change up the guts that make it function, though. Because if you have to replace the float or the fill valve, you know, I guess the fill valve is technically going to be above your head at that point. But to actually, like, change out stuff within the tank, I can imagine that's probably a little bit more challenging to do. Maybe more or less so than compared to, like, I guess the parts on, like, a urinal. It's a little different in its own regard. I mean, the most important thing I've ever learned in the plumbing space is that everything's gravity fed after you flush or run the sink. So if the pipe is not rolling downhill at a 2-degree pitch, then it's not going to go where it needs to go. And then you get to call one of them plumbing companies and spend $1 bazillion. The water level in the UK toilets tends to be lower, just exchanges by water coming in. See in the USA toilets empty by the bowl and then fill it back up somehow. Yes, and that somehow is the water line that feeds in from the bottom corner of the tank in most cases. Usually it's the lower left-hand side of the tank. And the water feeds up through the bottom of the tank. And then there's a ballast on the inside. Oop, I got us out of that. There's a ballast and a float, and when you flush the toilet, the flange goes up, the water goes down, and then the float drops, triggering the valve to open to refill the tank until it hits the shutoff height, to which then the little float floats back to the top of the tank. It hits its shutoff, and then boom, you have stopped filling the tank with water. His waistline ran uphill? Oh no! Oh, and a black tank too. Oh, that's just uncomfortable. Oh, howdy, Pyro. This is a different board. I'm starting one from the ground up. The most challenging thing, though, with the American toilets, though, is that you got to be careful when it comes to leaks, because if there's water leaking at that fill valve, or if it's slightly overfilling, it'll leak over the top of the overflow tube, and you'll start losing water. Now, the problem with that is that your water bill is going to skyrocket because the tank technically never shuts off. And even just a couple of drips over the course of an entire billing cycle could become awfully expensive in a hurry, which is generally less than ideal. Oh, you know what? Actually, speaking of water bills, I actually learned something about American water companies, and that is that your meter reads the raw values of the water that goes through the device that is attached to the plumbing. Howdy, Blackhawk. Welcome on in. We're talking about plumbing while I'm putting together a pronoun board. And I always thought that the values that were reported back to the water company were just the raw values of the meter when they would read them. Now, the cool thing about the way that the water company does their thing is that they have this big network of meters or substations and the meters. Now, on a lot of cases in more rural areas, they just go around in a truck, they drive around, and their truck has the hardware to read your meter from outside your house. So they never usually have to get any closer than your driveway to be able to read how much water you've used in a month. And then that information gets relayed back up to the main office, and then that's how your bill comes. But the thing that always blew my mind was the fact that I always thought it just reported how many gallons you use. Turns out it's actually slightly a little bit more complicated than that. Not only does it not give like a perfectly round number that it works off of, it's how many cycles that go through the meter. So if the meter equates to, say, just for easy math, 10 cycles of the meter to go around to equate to a gallon, then that means that they're reading the raw amount of times the meter spun around to equate to how many gallons, which means there's this thing called a multiplier that's involved in what determines how much water you've used. Why is that relevant, and why should you care? Well, that's pretty easy. If I used 10 spins of water in a billing month, and the multiplier in the billing system's entered incorrectly, I can get charged for a theme park worth of liquid when I didn't even come close to using that. So it's no surprise then that, a lot of these different utility companies have mechanisms to, open up a query if you run into a problem. And that is actually a big part of how that stuff functions. Oh, you are completely correct, RX, on that front. As someone, now naturally, of course, me telling you this story naturally means yes, I do have some insight into it. And when you have to explain how one could potentially use a theme park's worth of liquid over, yeah, I should do the switch back first. That's okay. It generally tends to, you gotta get a little creative with that. There we go. All I can tell you, though, is that if you ever suspect that you've run into a problem and your meter is misconfigured, open up a query with your water company and have them check the reading at the meter, because what it'll end up telling them, if it's a good technician, is they could see how many spins that the meter does, and then how many, pennies of liquid you're supposed to get charged. But something like that generally is hard to catch, remotely speaking, because everything else looks the same unless you look at the billable units. But something like that generally isn't very common, unless you've recently had something changed out, like the actual meter itself swapped with a new one. That's usually when they would put in a multiplier, especially if the value is different. If it's the same, usually nothing happens. You just get billed as usual. But that's an easy way to, get people involved. But that's just it. Like any billing error, if you notice something, you get people involved and you work through it and you get it fixed. Sometimes it's more difficult to troubleshoot than other problems, but naturally, when is anything that's difficult easy? It's not, because it's difficult. I know that sounds stupid and less than creative, but honestly, it's the truth. And sometimes the truth is a little rough to work with. Oh goodness. That's not good. Yeah, if you're suddenly using a bazillion more gallons of liquid, there is obviously an issue. Either that, or the first thing they'll tell you is that there's a leak somewhere, which could potentially be true. Especially if there's a leak at the meter. Yeah, well, you're not wrong on that part. It's like anything else, though. Hold your professionalism, keep your cool. It might sting like a bee sting to sort out, but yeah, you get there. Ooh, that's hot. That's really hot. Wowzers. And then again, I did have to apply a heck of a lot more heat to that one. Ooh, we're going to give that a moment to cool before I trim that. But while I'm waiting on that to cool, so far we've got all of our LEDs surface mounted, and now we're working on the diodes. These are the ones that will make sure that our electricity only flows in one direction. So in the event of a reverse battery situation where the battery is installed backwards, like so, nothing bad happens. This particular project didn't technically need those, but I added them more or less out of practice. The reason I say that is that LEDs are light emitting diodes, and this project is literally nothing but them, so technically the electricity can't flow backwards in this project, because there's nowhere for it to go. There is no backwards. But these parts do have an orientation just like LEDs. That's what that little white line is to indicate where the white line on that goes, so that you install it correctly. Because otherwise, you're gonna have a bad time. Spin this a little bit. Okay. Okay. These are all installed nice and flush. I can certainly tell you though, for the next project, I'm definitely going to have these kind of components spaced a little bit further apart from each other. Definitely put these legs a little too close to each other. But again, learning experience. Alright, sitting nice and flush, looking good. I'm thinking... I think we'll just do the resistors next, and we'll just do the battery last. If I had made a mistake with one of these LEDs, we're just going to find out after we get it all together. I like how easy the board is laying in this configuration. So I think we'll run with that. We'll do our 9 resistors for the red LEDs. These need to be 2 volts, or these are 2 volt each, so that means that we have to protect it with a 100 ohm resistor in this circuit configuration. So we've got, I think I said, what, 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, and that's this upper row right here is to where those get installed. Now, the nice thing with these is that the color code is the same, forwards or backwards, so there is technically no... Oh, well, for starters, resistors don't have a polarity to them. You just stick them in the board, electricity flows from one side to the other, which means that these don't need... You don't have to worry about putting one of these in backwards, but I like to line up the colors on the resistor so that they look nice. But as you can tell with this particular one, the 100 ohm is 3 black lines, and it just so happens to be 2 brown lines to indicate the tolerance of it. So I don't have a way to not put these in the same across all of them. Nice thing is that these do pop in with a decent amount of resistance, so I'm going to pop them all in and then I'll just clip them as I go. But this will allow me to preload the whole row. At least the one thing I don't have to worry about is shorting anything out, because The battery supply isn't installed yet, so none of this is live, which means that if my soldering iron touches anything, it's fine, because everything's off. Okay. Yeah. I don't want to zoom this in too close, but I would like you to be able to get a better idea of what I'm doing there. Well, I spoke too soon. I had a couple of these left on me while I was gone, so they're not sitting flush. That's alright. What I'm going to do is I'm going to heat up the leg that stood up a bit and just push it back through. I'm going to try to do that with something that won't burn my hand. Actually, no, let me do this with a set of pliers. You'll see what I mean there, how a couple of the components stood up. I didn't feel them back out on me, which is why I just went down the line, but that's easy enough to fix. I say that as I'm going to struggle really hard to show you this. Really? Howdy, King. No, what? What is that closed captioning? That was not too bad. That one is way too out of spec. I might actually just rip that one out, put another one in its place. Way too high. Well, maybe not. That one pushed in. Okay, let's see if we can get the other side. Closed captioner, what are you doing? Are you misbehaving? It doesn't know. That's down enough, I suppose. Yeah, that'll be good enough. I have been King, by the way. I'm hoping you're handling this heat well. I know some of us are doing the best we can. Yours truly included. Okay. So then these are the ones that are going to take the place of the 2-watt 47 ohm resistors. They're the same color bandage, but they're a lower wattage, so they're smaller, which means they'll sit flush in the board. Which is good, because we need a lot of them. $39 in total. Which is funny because that equates to most of the roll. This is what we're using, this is what we're not using. And as I had mentioned before, the colors on these, it doesn't really matter. That's going to sit nice and flush. That's going to look good when that's done. They sit nice and flush like that. Now, if some of you are wondering, though, as I had mentioned, that these are 1 watt instead of 2, are the legs any different in size? The answer to the question is yes, they are a little smaller, but because the solder fills in the hole just the same, it doesn't really make a difference for the physical aspect of this project. The problem you run into is if you had a component that you purchased that was the other way around, if it was, bigger. Because if I had a board that was designed for 1 watt and I had 2 watt, well, then that's not going to fit through the hole and that won't work with the board. But you can't go the other way as long as your application allows for the smaller component wattage wise. And in my case, it's fine because I did not need 2 watts of power to begin with. Excuse me. I do apologize that I'm a little bit more quiet than usual. This does require a little bit of brain power. I mean, granted, I'm kind of to the point, it's just kind of follow the shapes at this point. The green LEDs, I did have to install reverse polarity because of the mistake I made in the diagram before I ordered it, but I've already gotten past those parts. That was these right here. It's fun. For some reason, this station reminds me a lot of Undertale. Got a very Undertale-y vibe to it. I have to admit, I am looking forward to whatever the next project ends up entailing, because I could definitely tell you there's going to be a microcontroller involved, and that's going to be different components, different pieces, chips with multiple legs. I'm still going to probably stick with the through-hole components like these, where the component goes through the board, because that's something that I know I'm capable of actually putting together. But I'd be lying if I didn't say I wasn't excited for whatever ends up being the next thing I tend to cook up. I'm enjoying this. It's fun to think of, you know, what cool thing comes next. But as someone who tinkers all the time, that's a thought that's going through my head all the time. Nope, got one more on the bottom. And then all we'll have is the upper row, and then to attach the battery. And then we can test to make sure that my work is indeed functional. Since this is like my third time building this board, I have a good idea of, you know, which resistors go where, which is why I don't actually have the schematic in front of me this time around. Once you've already built one of these more than once, you kind of get an knack for where things are actually supposed to go. Well, we'll just have the upper section. But we're getting there. We're almost there. So the battery and then this upper row of resistors to put in. But I can tell you though, as someone who put together a couple of these, my ideal for how to assemble them really doesn't change. You know, the first go around I do it in small steps, and that would have involved attaching the battery pack, which I know again makes it a little bit more difficult to solder these components to stay put and flush, as I had screwed up a couple of them. But the if for some reason something doesn't line up, I'll show you how you take a component out and swap it with a new one. Pretty much the way that works is that you work all the old solder off by reheating it and then using kind of like it looks like a turkey baster. Even if I don't need it, I'll pull it out just to show you what I'm talking about. There's a little bulb, you squeeze it, and then you heat the solder up, and then you release it, and then it actually just uses a vacuum to suck the solder up off the board so that you can actually pull the component out. Yes, that is a little bit more easier said than done because, well, it's molten metal you're playing with, so you do have to be careful. And sometimes it doesn't heat up exactly evenly. Not to mention every component has two legs, which means that you have to get the solder off of each of them before you can take the component out and reverse it or replace it with a new one. So that does play in a little bit of this if you do make a boo-boo. But all these are all through component board, all through whole component board. Components in the board. So honestly, this is the easiest setup to make a correction if a mistake is made. The whole board is not ruined if something goes in backwards, or if one of these components just so happens to be faulty, which I have a functioning multimeter today, so if we do need to troubleshoot, we have the ability to do so. Because pretty much the only time that a fault would really be catastrophic to the project is if one of the traces that runs through the board was bad. We'd still be able to get around it, but that would involve manually adding a wire and then, you know, securing it to the board, which is obviously counterintuitive. The whole point of a PCB board is to not have little wires running around so that your schematic is, you know, set in stone, as the turn of phrase goes. Because once you've sent them to production like this, the idea is that you're not changing it again. Or if you were going to, you know, there's totally within reason if you wanted to make a project that had, like, say, the microcontroller on the board, and you make it so that some of the controllable legs you weren't going to use, but you had them wired on the board to a screw terminal, which then later you can add additional wires to the screw terminals without having to change the project itself. The breadboard or the PCB board stays the same. So there are ways to make permanent projects still modifiable, just the actual layout of the parts that you need to not move is what ends up actually on the PCB board. In my case, this project is very static in design. There isn't going to be, more things to change later on it. That doesn't mean that the project itself couldn't be improved, but that involves, getting new boards printed. Now, granted, I made a mistake with this one, so obviously the very first thing that we would do to improve this is correct the polarity on the green LEDs so that they're not backwards. Which, even though I don't anticipate making more of this board, I am going to fix that on the project file, just for clarity's sake. Because if for some reason in the future, say, 6 months in the future, I decide to order more of these for whatever reason, I would much prefer the schematic to be correct, instead of having to remember that half of the component, a third of the components have to be installed backwards, electrically speaking, to function correctly. Because I can't say for a fact, building that first board off camera was not a good time. I had to rip all those LEDs out before I figured out what I did wrong. Didn't waste the board, though. So, the reality is, even if you make a mistake, there's generally a way to fix it. Very rarely will you come across something in the computer space that can't be, fixed. Granted, price doesn't necessarily mean it's going to be cheap, but there's usually a way to get around a problem. Okay. We have now reached the point that we get to attach our battery tray and then test it out. And it looks like we're doing pretty good. I should have just enough solder on the roll here to finish this out. Which I wasn't going to run out. I have a fresh roll behind me, but it's nice to see that that actually does line up the way that I was hoping it was going to. One contact. And then we just gotta do the other side. It's always difficult getting that first one set because the whole thing kind of wants to wiggle around. But once the first one's set, it's usually pretty good to get the other one. All right, so we got a nice clean contact on the pad there. All right, let me just take a moment and take a good look at this to make sure I have everything installed correctly. Well, I didn't miss any solder points, so let's install our battery and give it a try. Okay, first we're going to do switch number 1. And there we are. Nice and bright, and all of them light up, which is perfect. We'll do switch number 2. That gets us our S and She. And then I'll turn on the last one to check those as well. Yep. And that is the T and Y and they. Which if we wanted to see that configuration, we just have to toggle off yes. So that not only confirms that everything does function, I did install all of the LEDs correctly, which helps a bunch. The switch pack is nice on that one. Yeah. So just like that one's done. Now, something I did want to touch on the last time we were chatting, that I do want to complete that thought since I took it out anyway, was the way to check the resistor. I briefly had mentioned last time, and I was rudely interrupted by my meter dying, if you weren't sure what the resistance of one of your resistors are. Yes, there's color bands on all this stuff, but the reality is sometimes you can't read it. Could be eyesight, could be the colors aren't very defined, could be an old component and they're just hard to read. So by putting our multimeter into resistance mode, all I gotta do is probe 2 ends of one of these, and that gives us 46. Oh, a little hard to get there. Make slightly better contact with it. These 46.6 or 47 ohms. These are not going to be perfect across all of them. So this one's going to read 46.6. This one's going to read 46.6.7. And then up here are our 100 ohm. So if we read one of these, we got 99.2. And then if I check this one near the end, 99.1. So that's a really easy way to check the resistance of a resistor if you're not sure what the resistance is. Now naturally, if I did not know that these were lower resistors, right? Because I currently have this set to 200 ohms max of resistance. If I truly didn't know, I would set my meter to the highest setting and work my way back down. So set to 20 mega ohms. Hit it with the test leads. And see it come back with 0, which means if I'm set too high, let's go down to 2 mega. 0, which means I'm too high. 20 kilo ohms, still too high. That was 200 mega ohms. That one's 20 kilo ohms, which again is a little high for our reading. It does come back with a number, but we can see here we're coming in at the 2K setting at 0.045, which is in fact 45 ohms, because we can just move the decimal point 3 places. Or I could set it to 200 at the highest setting, which gives us a flat 46, 47. And that just involves moving the decimal to figure that part out. And then when it comes to our battery, I had mentioned that this battery has a nominal voltage when it's working of 3.7. So if we put this into battery check mode, we can see that we're getting 4.1 volts. Now, why is this higher than the nominal voltage? Is because I charged it. So this at a full charge is like 4.2 volts, but once it's under load, it's usually operating at about 3.7. So if I pop our battery back into our project, turn it on at maximum capacity, and then I check our voltage to see what we're reading, you can't see it because I put the screen out of frame. Alright, so we're reading it's still about 4 volts. Now obviously as the LEDs run, it's going to consume power and it's going to dim, right? So as time goes on, these will get less and less bright. Something that I found kind of interesting is that the S in Qi is 2 volts, and then the rest of these are 3.3. When I left all of the switches on in full configuration, like this, just to get an idea of how long it would run the battery for before it would die out, I always found that after 3 separate attempts that the T and the Y would be the first to go out, and then you'd have a very, very, very dimly lit Qi. The S would be the brightest, and then the H and the E would still somehow be lit, which I found funny because they're 3 volt or 3.3, which is exactly what these are. But even with the switches completely on and the separate paths, still through the resistors, even though they don't light up when the battery gets low enough, there's still electricity passing through them, just not enough to make them illuminate. I found that interesting because you never quite know, what to expect in that regard. But yeah, that makes up our couple of things I wanted to touch on the multimeter. I'm glad I was able to cover that. We got a functioning meter this time around. All right, I'm gonna clean up the iron here. It's good. Let that cool off. Out of curiosity, does anybody have any questions in regards to what I've shown them, or something that I may not have covered? I'm curious if there's any thoughts from any of you out there. My tracking has lost itself. Hey, let me reset myself here. Aha, that's better. It's nice to be in frame. Nope, alright, cool. I think so. It's fun. It's fun to play with. Alright, cool. As for the next time I'm going to be on, let me see. I normally do this on Wednesdays. Let's see. Today, it's that day of the week. I don't know when I'm going to be live next, but it's going to be Wednesday. I've got some stuff coming up over the next couple of weeks. This is going to be a busy month for me, so I may not see you until the beginning of next month. If not, we'll do something silly, I'm sure. But with that, let me see who we're going to go say hello to. Let's see here. Okay. All right, cool. I typed it right. Okay, we are gonna go say hello to Jay Hutch. He is a streamer that does VR chat, other games. He also does his VTubing, similar to what I do here. Well, I mean with the model, I mean VTubing. Ooh, so super spooky. Right now, Jay is playing Subnautica. So I want to thank everybody for swinging by. I am very much looking forward to whatever the next project is going to be. Like I said, we're going to do one from start to finish.
just need to work through that. I have not forgotten about the 30 Days in Space franchise. We are going to finish that. I wanted to build these because I plan on using them over the next couple of weeks. So I figured I might as well show you all what I've been up to. And I will bring you along for the next one. So with that, I wish you all a pleasant time zone. Bye-bye.